All right, let's go.
Good?
Okay, we're good.
One sec.
We're good.
All right.
Okay.
What's up?
Woo! All right.
All right. So,
Go.
you go.
Wait, what?
Start. Okay. So, right now, the most powerful AI models in the world all run on one thing: specialized chips doing math, trillions of computations every single day. And companies are spending billions of dollars just to keep up.
Most of these chips are GPUs, which were originally designed for gaming and later adapted for AI. But a few years ago, we kept hearing about this new kind of chip appear in random Twitter posts and articles, a TPU.
It turns out, these chips are super mysterious. They're a specialized chip only designed for AI and not for things like graphics and games.
Mike.
Oh my gosh.
Is it good?
Whoops. Stuff happens. All good?
It's okay.
Test. Okay. Turns out, these things are super mysterious. They're a specialized chip only designed for AI and not for things like graphics and games.
This is a really simple idea, but it's what allowed Google to run and train their own models, like Gemini, up to 1/10 of the cost compared to using GPUs. Oh boy.
Okay. But when we tried researching about these TPUs, we couldn't really find anything about how they worked, only vague details about what they were. And turns out Google decided to keep these chips completely closed source, meaning we couldn't really go to a store and try to buy one or try to learn about how they worked.
And I thought this was absolutely insane. I mean, like, a big public company was like hiding something that was clearly groundbreaking. And so I started reaching out to like literally anybody who could explain this stuff to me. And that kind of led me to going to this industry event for AI chips. And like point blank, I was there and I asked an engineer, like, okay, what the heck are these TPUs out of frustration? And so I never got a straight answer. Instead, I got like 10 minutes of just like technical yap I couldn't follow. And so that night, I called up Xander on Discord and I'm like, dude, okay, I'm like trying to learn about these TPUs, but I keep getting cooked.
And the more Evan spoke to me, the more I got hooked. See, I've built many computer-related projects in the past, and I was really intrigued by the promises of these TPUs.
And around the same time, I got inspired by Evan's tweets and started learning about AI hardware stuff on my own.
And so eventually, we made a group chat and decided that the best way to learn about this alien technology was like to maybe try and create it from scratch. And so at first, we kind of just like stared at this whiteboard for like the whole day. We really wanted to design this AI chip, but being kind of stupid second years, we had no idea how AI worked or how chips worked.
So we went all the way back to the basics. Let me quickly walk you guys through what we learned. AI works in 2 stages, inference and training. Inference is the process of getting a response from a chatbot, and training is the process of making that chatbot better.
Turns out, inference is basically just multiplying and adding numbers. See, large models perform millions of these, so building hardware that could run like a ChatGPT level network was going to be impossible for us. So we decided to shrink the model down to a tiny little one so that we could better understand it.
But how do we build a chip to do these millions of calculations? Well, it's actually not as complicated as it sounds. First, we made a hardware unit that can multiply and add 2 numbers. Then, we made a grid of these hardware units to let them communicate with each other. And now they can multiply large groups of numbers called matrices. Then we just added some addition units, some special function units, and some memory to be able to do larger calculations. And boom, you have a toy TPU that can run a very small machine learning model. The next step was okay. The next step was implementing this in code to see if the math actually worked, and it did. So here's a quick video of when we got our simulation working.
Yo, we may have code. We may have code. Wait, on. Choose a sign. Yes.
Negative 1240.
Is that negative 12? That'd be so dirty.
So yeah, this was kind of a big deal for us because it was like our first milestone. So I tweeted about this progress, and it ended up reaching a lot of people.
Including me. At the time, I was super interested in making AI chips, but I didn't have the most important thing, people who actually care about this stuff. So at this point, TinyTPU could run inference of a small neural network with a few inputs. But the obvious next step was to try and run bigger and better AI models, like the ones that power ChatGPT and Claude. And I happen to know the math behind these models super well. So I reached out, and eventually we met up so that I could teach the other three exactly what was going on. And we spent almost half a day whiteboarding. And I guess you could say that this was my welcome moment to the team. So now we moved on to our next challenge, training.
So, in a nutshell, training an AI model is kind of like trying to create a function to best fit a bunch of different data points. But you see, when you're dealing with a massive amount of information, this isn't as easy as it sounds. That's because it requires a lot of calculus. And it turns out that computers absolutely suck at doing this.
Well, the thing is, after scratching our heads for like a few days, we realized we didn't need to do any calculus. Thank God. See, the thing is, the training algorithm simplifies down to the same multiplication and addition that we did during inference, but in reverse. We didn't need a whole new system. We just needed to switch up the order of the math. And with that, bam! Our simulation of a chip could now do the two big tasks required in AI: training a model and running it. Google's TPUs, they do the exact thing we've built, just multiplied millions of times over in a data center. Now, this is all a little abstract maybe, and it may have flown over your heads, so to show you some results, we decided to put our simulation onto an actual chip that's programmed with an AI model to show you all today.
Whoa. So you guys have been wondering, what have I been doing for the last 2 minutes? So we actually have a live demo to show you. So we built a tiny machine with our TPU and an AI model programmed on it to recognize handwritten digits. So Surya is always making fun of my handwriting. We're going to get him to write a number and see if the AI model is smart enough to recognize it. So if you can see in the camera that the hex is 0 so that the AI model is smart enough, let's get him to write a 1. His handwriting is worse than mine. Can you believe it?
That should be a 3. Okay, there we go.
There we go. Okay, the point is, I want to emphasize that the math that we used to do on the whiteboard by hand is happening on our chip right now.
And so after we did this, we wrote an article explaining how TinyTPU worked and also our process of developing it. And it got a lot of views. The next day, we all woke up to DMs from this random guy named Jonathan Ross.
Yeah, who is this guy? Who's this guy? We searched him up on LinkedIn just to find out. He's the inventor of Google's TPU. How crazy is that? So obviously we had to go and see him in person. And this by far was the best full circle moment of our lives. Getting to see the inventor of what we just spent 3 months trying to reinvent ourselves.
But it wasn't just that, because the cherry on top was the people that we inspired. Seeing our resource being used to easily learn about TPUs, a resource that we first wanted when starting out, it was really, really heartwarming.
And so in 4 months, we went from 4 students who had no AI or hardware experience to reinventing this arcane chip from scratch and meeting the guy who started it all. It's honestly been a wild and bizarre adventure and an incredibly rewarding ride.
And so, in conclusion, we cooked. And we can all collectively say that building something insane with your friends is a 10 out of 10 experience. So go do it yourself!
All right, let's bow. Okay.